All right, geometry, this is your homework. The problems were all odd, so I'm not going to go over all of these. You guys can check the answers in the back of the book, and I want you to do that. But this was just to go through a couple of them that are similar type concepts to make sure you understood. So just a review really quick. Number 9, 11, and 13, they asked you to find the geometric mean. So the geometric mean between two numbers was kind of this situation. Basically, it satisfied this kind of fraction here. So x is the geometric mean between a and b, such that a divided by x equals x divided by b. And we said in class what you could do with that is it ends up giving you this like x squared equals a times b. And if I simplify it even more, I'll kind of do this in pink here, you'd square root both sides. And so x would equal the square root of a times b. So all we're going to do on all these problems is we would just multiply like 25 times 16 together. That would actually give us 400, and we square root that. So I'm taking my two numbers like a and b and multiplying them together, and I find the square root, which in this case is 20. Okay. We're going to focus on just the positive value, right? You could have a plus or minus there. We're only focusing on, for geometry, the positive value. Take a look at number 13. It's very similar, right? I'm going to do 18 times 1.5. And what I get from that is 27, so the square root of 27. But we're not going to ever leave our answers this way. So we've talked about this before, right? We want to simplify our radicals. And so this is actually 9 times 3. And the square root of 9 is 3. And the square root of 3 is actually just the square root of 3. So I do want you to simplify these. Obviously, if the instructions say round to the nearest tenth, you can also do that if you want to punch in your calculator, but I actually prefer these answers for our class. They're cleaner, they're nicer, gives you a little less to have to worry about. All right. So again, you could check number 11 in the back. I'm just trying to do a few of these. Number 15, they asked you to write out the triangles and write a similarity statement. So I'm going to take this guy here, okay, and we're going to move him. If I can get this to work out. Okay. That one's going to look like that. And you've got these other ones, and I can't like rotate them perfectly on this, but what happens is, and it's good to note these things, so this angle and this angle are going to match. So as I take this one and I do move it, if I were to try to redraw this and kind of like rotate it around so that it matched this one, it would look, that was terrible, like this, at your 9-degree and this angle here. So what's going to happen is we're going to end up flipping all of these around. So what I have for these two, and again, I didn't label them, and I'm sorry I didn't do that. You've got like triangle X, Y, W is similar to, and then the red one, we kind of moved around. Originally it was X, Z, Y. Well, I know Y is the angle that I marked. I know Z was my 90-degree angle, and so X is this other one. So just seeing how they're kind of drawn similarly helps us to identify, well, the X is in the same place as the Z, the Y is the same as the Y, and then the W is the last one. And we're going to say that's similar to, let me kind of simplify some of this stuff. Okay, we're going to get rid of the red one. We're going to draw now the blue one here. And similar, I'm going to draw this one. If this side is 90 here, then I do have 90 on this side. And this angle is my other angle. It's going to match with W here. So when I pull this over, if I were trying to rotate that around, you're going to kind of like flip it so that the 90-degree angle goes over this way. So it would look like this. My W is still going to be down here. My Z is my 90-degree angle, and my X is here. So I have triangle Z, oh, sorry, we're going back to this black one. So they start with X, so we're going to start with Z, 90-degree angle. Then we went with Y. Well, I didn't label that one. That's this guy here, so that's X, and then W. Okay, so you really do want to pull these apart to try to figure out which ones match up. Again, you can check 17 in the back of the book for that one, okay? All right, number 19, and again, I'm not going to do all these, so 19, 21, 23 are really similar. We'll just do one of them. What we did in class is we started, one of the ways to do this, not that you have to do it this way, is setting up a little table. You've got the short leg, the long leg, the hypotenuse of every triangle, and you've got the small triangle, the medium triangle, and the large triangle. Right? And we just said, you just plug in the numbers as you have them. So let's just start. We'll go with the smallest triangle, which would be this guy. The short leg is 6, the long leg is 17, and the hypotenuse is x. And this is my 90-degree angle, and then you're just deciding which one of these is shorter, right? So I put those in. The next one, we'll go with this other side. Here's the medium triangle. And what I have is the short leg is the 17. All right. If you ever can't tell, this is where this method is a little harder to do. If you can't tell which one's shorter, which one's bigger. What I'm going to do really quick, I'm going to put another letter right here for a minute. I'll just put a little question mark. I don't know what that one is. That's the long leg, and the hypotenuse is z. Okay. And then I have the biggest triangle, the biggest guy here. You got the short leg. Again, I'm gonna say this is x. Z is the long leg, and y is the hypotenuse. Now again, this is where there is some speculation, and we've talked about this, right? Okay, I can't guess on this. How do I know it's the short one? The nice thing about these triangles is there's not a way to like be tricky because it is constrained being a right triangle. So I'm going to say this is okay for us when we look at it to say, well, which one is shorter? If you pull out a ruler, you could do it that way, but you don't have to. So then we just said pick any piece, right, that you want. You can pick different different sections of this little chart that we have to match up. So what I would do on this one is I could find, I could do these guys right here and make that a fraction. Now, what I'm going to do is I put a question mark there, but I think you guys know, you guys are sharp, that this piece right here is actually y minus 6. So I'm going to erase this guy, and I'm going to put y minus 6. It's the whole thing minus this piece, which is 6, so y minus 6. So I could actually set this up. 6 over 17 equals 17 over y minus 6. So you end up with 17 squared, which is 289, equals 6y minus 36. So we're going to add 36 to both sides, and you got 6y equals 325. Divide by 6, divide by 6. I added, okay. And then, so when I divide that by 6, I get y equals, sorry, I'm writing off the screen there, 54.166 repeating. So once I have y, I would then try to find x or z. And so you look at another way to do this. Again, now that I have y, you can do this section right here. Or I could also do, and this is the one I'm going to do, let's do another color here. Do this blue. I could do this guy, this guy, this guy, and this guy. So we're going to do that one and try to write in that color over here on the side. You've got 6 over x equals x over our 54.166. And I did that one because I actually have that on my calculator still, right? So I'm going to multiply that by 6. It's actually going to get us back to 325 equals x squared. And so x equals the square root of 325. Let's see here really quick if I could break this down for us. That's going to be 5 to the square root of 13. Okay. You could get decimal version as well, but that's the clean way to do it. Right, and then what's nice is, and I want us to always be catching these things, okay, you got a right triangle here. So now that I know what x is, and I know what y is, I can figure out what z is just by doing the Pythagorean theorem. And I'm going to leave that for you guys. Again, this is just a quick summary of some of these problems. So you might end up with some decimals like this, and that's okay. Try not to clear your calculator as often as possible, and then use things like this to make it easier so you don't have to deal with those longer decimals. All right. jumping all the way down to this one. This one's modeling. It's really just making sure you're setting it up right. So I just want to make sure we're reading these carefully. So as I look at this problem, Michaela's using a book to sight the top of the waterfall. Okay, so she knows it's 90-degree angles at the edge of the book, and the horizontal distance of the waterfall is 28 feet. So that's where you've got this horizontal distance away, to the waterfall. So 28. Okay. And then find the height of the waterfall to the nearest foot. And so what they want is how tall the overall waterfall is. And one of the things they gave us, I don't know if you see it there, this is our x. They gave us 5, and 5 is her eye level, right? So they gave you that little piece. If I were to redraw this, what you have is this distance is 20, 28. And then you have this distance is 5, and then you're trying to find the entire thing here. Which again, what I just typically do is I'm going to find this one. So the very first theorem we learned is that the altitude is the geometric mean. It's the one that's going to be repeated between the two parts of the hypotenuse. I'm going to put y here. So you got 28 squared is 784 equals 5y. So when I divide by 5, I get 156.8, and it says round to the nearest tenth of a foot. So I put 1 decimal place. Okay, so make sure you're setting these up right, but then you're just using the rules that we learned from before. All right, moving along pretty quick. This one says find the geometric mean, and I just thought this looks fun, right? Geometric mean is the number that is between these guys, and all they're really asking us to do is multiply together. So I've got this some like ugly math here, right? Just in terms of these guys being multiplied together. So 3 the square root of 2 divided by 7 times 5 the square root of 2 divided by 7. Okay, well, when we multiply things like this, you really are just going to multiply the numbers that are in the same places together. So you got 15, the square root of 2 times the square root of 2. Oh, I keep choosing blue there. The square root of 2 times the square root of 2 is just 2. And then on the bottom, you've got 7 times 7, which is 49. So I end up with this entire thing being 30 over 49 equals x squared. So if I continue and I square root both sides, I've got x equals the square root of 30 over the square root of 49. On the bottom, you end up back with 7. And on top, I try to break this down in some way, shape, or form, and I can't. It's actually not possible. And so you just leave it as the square root of 30 over 7. Okay. Again, I could punch it in my calculator, but there's really no reason to. This is a nice, clean answer. It's not rounded. So don't be afraid when you see these. Just remember all you're doing is multiplying the same things together like we did here, right? All right, this one, again, very similar. I'm actually going to set this one up using my little table. Okay, I think that's a nice way on some of these bigger problems where you have to find a bunch of things. Short, long, hypotenuse, small triangle, medium triangle, large triangle. And we're going to go small triangle is this guy. So the short leg is, I don't know, it's this one right here. It's actually 2 the square root of 3 minus x. We do know, I guess. Y is the long leg. This is the square root of 3. Short leg here, y. Long leg, x. Hypotenuse, z. And then we have the biggest triangle. Short leg, the square root of 3. Long leg, z. And the hypotenuse is 2 the square root of 3. So if I'm trying to find this, this is really the starting spot. I'm going to use the 4 corners. And once I get what x is, I can figure out other ones. Again, always looking for Pythagorean theorem in here. Don't forget that. That's a nice shortcut. So 2 the square root of 3 minus x over the square root of 3 equals the square root of 3 over 2 the square root of 3. Like, wow, that's a lot. These actually can reduce. so 1 over 2. And so I have 2 to the square root of 3 minus x times my 2 here equals the square root of 3. So 4 to the square root of 3 minus 2 equals the square root of 3. I'm going to, 2x. Subtract 4 to the square root of 3, subtract 4 to the square root of 3. You get negative 2x equals negative 3 to the square root of 3 divided by negative 2. All right, x equals 3 to the square root of 3 over 2. Okay. So then I would plug it into one of the places. You could plug it in some other places. I'm gonna plug it in here, 3 to the square root of 3 over 2. And then what I would do is I would do this little section here. And so what that would look like is 3 to the square root of 3 over 2 over z equals z over 2 to the square root of 3. All right, z times z is z squared, and then you end up with 6 times 3, this times the square root of 3 is 3 over 2. So we got z squared equals 18 over 2, which equals 9. And z squared is equal to 9. Square root z equals 3. Okay. Hopefully that's helpful. You're seeing that. And then the last one I would do is I would do these four. Right. Again, we can use any up and down, left and right, as long as we're picking ones in the same column. So look at the way this one works out. Because now we know what z is. It's 9. Oh, sorry, it's 3. My fault. So we've got y over 3 equals the square root of 3 over 2 the square root of 3. And again, these are going to cancel out. So I end up with 1/2. Well, that means y is going to be 1.5 to keep that ratio, right, of 1.5 divided by 3 is the same as 1 over 2. So y equals 1.5. Okay. The beautiful thing about these is I could have done y a different way. Actually, since I had z and x, I could have done the Pythagorean theorem. I just don't know if I want to do the Pythagorean theorem with something like this. But you could. And it's really nice when those things work out that you could do it in a different way. All right. This one, just trying to make sure we're reading carefully. Again, I know I'm going pretty quick here. Geometric mean of a number and 4 times that number. So you've got a number, x, and you've got 4 times that number. All right. Sorry, I'm writing that really weird. You got 4 times that number. You should get 22, right? That's the final answer. And we kind of thinking through this is like, okay, the geometric mean is 22. So normally we have this formula. Let me write it this way. You've got, this is the formula, right? This is the geometric mean, x, between two numbers, a and b. Well, these are your a and b. This guy, let me write that differently. This is your b, and this is your a. And then like this guy here is your geometric mean. So what we're going to end up with is x over 22 equals 22 over 4x. And when you cross multiply, we end up with 4x squared equals 484 divided by 4. X squared equals 121, and x equals 11. All right. If they asked you, which they don't, it says what is the number, that's x. If they asked you for the other number, if they asked for the numbers, it would be 11 and 44. All right. This one, again, don't let the t plus 1 throw you off. But this is the very first theorem again we went through is this is the geometric mean. If I'm not using the little table or the chart that I've used, if that's too confusing, you just have to know how to set them each one of them up between 24 and t plus 1. So when I cross multiply, I get 144, these two, equals 24t plus 24. So I have, we'll subtract 24 from both sides. Get 120 equals 24t, divide by 24, divide by 24, and t equals 5. And you get your answer, okay? 37 is similar. All right, I'm gonna kind of simplify. You actually get 36 equals, when I cross multiply these, m squared plus 5m. All right, I didn't set it up. I'm gonna trust that you guys can do that in terms of this is your geometric mean. But when I see an m squared and an m, this means I have to factor. And so what I'm doing on this problem is thinking of two numbers. Okay, this goes back, and we're going to review some of this factoring, but you're going to see it come up in this chapter. What two numbers multiply to 36? And I'm like, okay, 1 and 36, and 2 and 18, 3 and 12, and I've got 4 and 9, and I like these guys because I know if I do 4 minus 9, then I get negative 5. So I'm going to put plus 4 minus 9, and I set each one of these equal to 0. M plus 4 equals 0, m minus 9 equals 0, m can equal negative 4, or m can equal 9. And this is the only one that makes sense for our context, right? In geometry, this has to be a positive value, okay? So hopefully that's helpful. Again, this is the very last problem. It's going to be the hardest it's going to get, where you have to review some of that factoring. Okay. Sorry. Hopefully it's helpful, guys. I know it's quick. I want to follow up with you guys when I get back on some of these concepts. We'll go over that worksheet together if you have questions on that. But hopefully this is helpful if there were some of these particular problems that you had. And again, I'll see you on Wednesday when I get back.